Okay, warm up for 6.2. We're given set A is 18, 6, negative 3, and 12. They want us to determine all the elements of set A that are in the solution of this inequality. So we have to check each one of these elements, substitute it into this inequality, and see if it comes out true or false. So it's one step at a time. 2/3 times, we're going to substitute in the first one and check to see if it works, times 18 plus 3 is less than negative 2 times 18 minus 7. 18 divided by 3 simplifies to a 6. 2 times 6 is 12, plus 3 is less than negative 2 times 18 is negative 36 minus 7. 12 plus 3 is 15, is less than negative 36 minus 7 is negative 43. Is 15 less than negative 43? No. So 18 is not one of the solutions. Let's go ahead and check 6. 2/3 times 6 plus 3, is that less than negative 2 times 6 minus 7? 6 divided by 3 is 2. 2 times 2 is 4. 4 plus 3 is less than negative 6 times 2 is negative 12 minus 7. 4 plus 3 is 7. Negative 12 minus 7 is negative 19. Is 7 less than negative 19? No. So 6 is not a solution. Let's go ahead and check negative 3. 2/3 times negative 3 plus 3. Don't forget to use order of operations too. Sometimes that can mess us up. Substituting in negative 3 minus 7. These guys are going to simplify off to negative 1. And 2 times negative 1 is negative 2. Plus 3 is less than negative 2 times negative 3 is 6 minus 7. Negative 2 plus 3 is 1. 6 minus 7 is negative 1. Is 1 less than negative 1? No. So negative 3 is not a solution either. One more. 2/3 times negative 12 plus 3, is that less than negative 2 times negative 12 minus 7? These guys simplify to negative 4, and negative 4 times 2 is negative 8, plus 3 is less than negative 2 times negative 12 is positive 24 minus 7. Negative 8 plus 3 is negative 5, is less than 24 minus 7, which is 17. And is negative 5 less than 17? Yes, it is. So the only one of those elements that actually work that is a solution would be negative 12. 6-2, solving systems using substitution. You can solve a system of equations algebraically two ways, by substitution or by elimination. You guys have already learned how to solve a system graphically. Now we have to do algebraically, because algebraic is a really good method. Both of these are algebraic because it works no matter how ugly the equations get. Whether your solutions are fractions or decimals, you still can actually get to those answers by substitution and elimination, which is harder to do when you're doing it with graphically. Substitution method. Solve one of the equations for a variable. Then substitute that expression into the other equation. This method is preferred when one of the equations is already solved for a variable. So you guys are going to have to know how to do both methods, but if they give you the two equations where one of the equations is already solved for either the x or the y, or any variable that's in the equation, then substitution would be the easier method to go. If it's not and you have to use substitution, then you're going to have to solve for one of those variables. So let's go ahead and look at an example. Make sure you pause me if you need to keep up with the writing part. Okay, here's my example. It says x equals negative 2y plus 4. 2x plus 4y equals 8. Notice how in the first equation x has already been solved for. It's equal to negative 2y plus 4. So I actually can go ahead and substitute that expression in for x, which is into the other equation. So that's what I'm going to do. I'm going to put 2, and we're going to substitute in this whole binomial into the expression for x. Remember, you're substituting in a binomial, so you have to make sure you put it into parentheses, which is going to force you into using the distributive property. Drop down everything else, plus 4y is equal to 8. Go ahead and solve by using the distributive property. 2 times negative 2y is negative 4y, plus 2 times 4 is 8, plus 4y is equal to 8. Combining your like terms, you'll notice that the negative 4y and the positive 4y actually cancel each other, and you end up with the variables going poof, and the ending statement is true. So therefore, I actually don't have to go any farther, because this is where it is all numbers on the lines. For example, all real numbers. For example, if I was to graph the first equation, I'm not going to, but it would end up being a line. And if I was to graph the second equation, it would end up being the same line, one right on top of the other, which means that every point is supposed to be on top of each other. Every point, which is an infinite number of answers, is going to actually satisfy both those equations because they intersect at every point. This doesn't happen that often. Usually, what happens is the two lines that you're going to graph are going to actually intersect at a particular point. So let's look at this word problem. A snack bar sells 2 sizes of snack packs. A large snack pack is $5. A small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did they actually, the snack bar sell? Well, let's go ahead and let x equal the number of snack packs, small snack packs. And we're going to go ahead and let y equal the number of large snack packs. Because I have 2 different variables, that's going to require me to build 2 different equations. You have to be careful with this. You have to read the word problem carefully. X is all the small packs, y is all the large packs. So if I take all of the small packs and add to it all of the large packs, I have a total of 60 altogether. There's one of my equations. The second equation is going to involve the money part of it. So I have $5 times the number of large packs, which we're letting be y, plus $3 times the number of small packs. If you add up all the money from the large packs plus all the money from the small packs, they made a grand total of $220. That's my second equation. Now we're going to actually solve this by substitution. So I have to either solve for the x or the y in either the first or second equation. The first equation would be easier because the coefficients in front of the variables are 1. So I need to either solve for the x or the y, and it really doesn't matter which one. Let's just go ahead and solve for the x, because either way we'll come up with the same answer. So x is equal to 60 minus y. We're going to take that expression for x, which is 60 minus y, and we're going to substitute it in for x. That's going to give us 5y plus 3 times my x, which is the 60 minus y. That's my binomial that I'm substituting in from down here. Make sure you put it in parentheses because you're multiplying it by the whole expression, which forces us to use distributive property. So we get 5y plus 3 times 60, which is 180, minus 3 times y is 3y is equal to 220. Combining my like terms, I get 5y minus 3y is 2y, plus 180 equals 220. We have to solve for y. So subtract 180 from both sides. These guys cancel. We're left with 2y is equal to 220 minus 180, which is 40. Dividing both sides by 2, I'm left with y is equal to 20. Now, that tells me how many large snack packs I have, but I still have to figure out how many small snack packs I have. So, if you go back to what we have here with this equation, I can figure that out by saying x equals 60 minus y, and I just figured out that y is my 20, and 60 minus 20 is equal to 40. So therefore, we're talking about 40 small and 20 large snack packs. Now, here's the deal, guys. You have two different equations, this one and this one. That anytime you have an equation, that involves a check. So because I have two equations, I have to do two checks. I'm going to go ahead and squeeze it in here. Check number one was my x plus y equals 60. So substitute in your 20 plus 40. Does that equal 60? And it does. So the first one checks. You have to make sure both equations check in order for you to confirm that your answer is correct. Take the second equation, which is up here, and substitute in 20 for y and 40 for x, and multiply it out and see if it checks. 5 times 20 is 100. 3 times 40 is 120, and if you add those two numbers together, you're going to get 220 equals 220. And it checks. All right, let's go ahead and try another problem. If you look at the two equations they gave us, both of them are in standard form, which is not very helpful because we need to solve for one of the variables. Look for the one where the coefficient is a 1, like this one over here. If you get y by itself, that would mean you'd have to add 2x to both sides. That would cancel, and you're left with y is equal to 2x plus 2. Take that expression, 2x plus 2, and substitute it back in to the other equation for y, because that's what y equals. Don't forget to substitute in using parentheses. So this is my substitution expression, which is a binomial, 2x plus 2. Drop everything else down. Make sure you use the distributive property. We get 6x plus 6. Drop down my 4x equals 16. Combining my like terms, 6x plus 4x is equal to 10x plus 6 equals 16. Subtracting 6 from both sides, that will give me 10x equals 10. Divide by 10, and we end up with x is equal to 1. That's my first answer. I have to go back now and find y. So use the equation you have over here and substitute in what you found for x, which is 1. Substitute that in to the, substitute that in for x in the second equation. And we end up with getting 2 times 1 is 2, and 2 plus 2 is equal to 4. So these are what I think my answers are. Now I don't know until I do my two checks. So check number 1 is going to be 3 times y plus 4 times x. Does that equal 16? That's my first equation right here. 3 times 4 is 12. 4 times 1 is 4. And does 12 plus 4 equal 16? Yes. All right, check number 2. That's the second equation. Negative 2 times x plus y. Does that equal 2? Well, negative 2 plus 4 is 2, and does 2 equal 2? So I now know that these two answers are correct.